Alright, here we're going to look at transformations of functions. Now, basically when we're talking about transformations of functions, we're really asking ourselves how we can shift, stretch, and reflect a graph of a function. Okay, so if I were to have a function, so say I have a function graph, maybe it's a parabola, right? So it's this U-shaped graph. Maybe I want to know what things can I do to its function, its equation, that'll make the graph shift upwards and to the right and then also widen it out. What would I need to change about this function, this maybe f of x function? What would I need to do to this function so that the graph is no longer at the center point, the origin, but instead it's been moved right and up, and like I said, it's widened out. So that's kind of what transformations are looking at. So for instance, just some basic transformations here. Let's say I let f of x be my starting function. Okay, so this f of x is my starting function. And let's say I add some k to the outside. Anytime I add k units to the outside of the function, that is going to shift the function up k units. Okay, so whatever that k units is, that's how many units the function will move up. Similarly, if I subtract k units instead, that's going to tell me how many units the function will shift down. So it'll shift down some amount of k units. Okay? So k, anything on the outside, is either going to move me up or move me down. We usually call these vertical shifts. With vertical shifts, we can actually have horizontal shifts. These occur when what we're adding or subtracting happens on the inside. So for instance, notice that this is notified by an h because it's going to move me horizontally, and it's on the inside affecting the x value. So anytime I take x minus h, this is actually going to do the opposite of what you may think. This is actually going to shift right h units. Okay, it's actually going to take me, if I had an axis drawn here, subtracting h units is actually going to move me to the right h units. It's actually going to move me to the right, not to the left. And then just like that, if I add h units, that's actually going to shift me left h units. That's going to be backwards as well. And the reason why that's occurring, for those of you interested in understanding why that's happening, why we're getting the opposite directions, is it has to do with when is the function on the inside equal to 0. Well, notice if I subtract h from the inside, I would have to plug in a positive h to get the inside back to 0, right? So if I subtract h units and that forces me to plug in a positive h, that's really going to move me positive h on the graph. And similar to that, if I look at this one, well, what would make this function's inside equal to 0? Well, that's going to be the case when I plug in a negative h. So a negative h is actually going to, or a positive h is actually going to move me negative h, because that's what I got to plug in to get 0. So the thing that you need to remember is that it's any time we have a transformation on the inside where it's being added or subtracted, it's going to shift us horizontally, and it works kind of backwards from what you think. A negative h will shift you right h units, and a positive h will shift you left h units. Okay? So far we've gone through verticals transformations, we've gone through horizontal transformations. Now let's talk a little bit about stretches and compressions. So with stretches and compressions, we notify this letter usually by A. Kind of tells us our amplitude, how much stretch the graph has. With stretches and compressions, anytime my A is bigger than 1, so in this case I have a 3, that'll act as a stretch on the graph. Anytime my A is less than 1, like this 0.24, that'll act as a compression. Okay, so just to kind of recap, k is on the outside, that's going to be a vertical shift. Any transformations on the inside being added or subtracted will be a horizontal shift. And then anytime we multiply something on the outside to the function, it'll either stretch it if a is bigger than 1 or it'll compress it if a is smaller than 1. The last transformation we have is a negative out front. If I put a negative out front, what that will do is it'll reflect me. And it's going to reflect me over the x-axis because it's going to change the y values. So if I had a coordinate plane, what it's going to do is it's going to take all the points that were up here and it's going to reflect them down, and it's just going to flip me over that x-axis. So this is going to reflect over the x-axis. Okay. And then just lastly, I just kind of want to summarize. This is a little bit more like an equation what you would typically see. So once again, I have the equation y equals negative a x minus h plus k, and this happens to be where a is bigger than 1. So in this case, where a is bigger than 1, I know right away that the a is going to stretch the function by a factor of a, whatever a is. The negative, once again, is going to reflect over the x-axis. The negative h does the opposite because it's on the inside, so that's really going to shift right h units. And then the k is positive and it's on the outside, so that's going to shift me up h units. Now, just lastly, some things to note if you are struggling with transformations a little bit. The way I like to think about it is with the k's on the outside, notice that the y is on the outside. So the k is affecting your y values. And if you think about a coordinate plane for a second, y's are here, x's are here. If k is affecting your y's, well, my y is my vertical axis. So if k affects the y and the y is the vertical axis, k is what shifts me up and down. You'll notice that h is on the inside and x is on the inside. So if h is affecting x, and I look at my coordinate plane, x is my horizontal, so h is what's affecting my horizontal. Okay, so k affects me vertically, h moves me horizontally. A I like to think as my amplitude or my altitude. It's telling me how much stretch is in the graph, whether the graph is going to be wide if a is less than 1, or maybe a is bigger than 1, and so it's going to stretch vertically like this. So once again, this is where a is less than 1, this is where a is greater than 1. Okay? And once again, that's just a parabola, but this works for all functions. In the next video, I'll try and have some examples of functions and go through the transformations of them.